Yeah, pi by 2 BPSK, which is introduced newly in 5G, right? So why this is used, you will get the reason low PAPR. But actually, how low PAPR is achieved with this? So if you see the normal BPSK constellation, it will be like this, right? So it will be 1, 0. This will be -1, 0. Now, PAPR, where is it coming? Peak. So this is coming at the power amplifier, right? So power amplifier has to switch its phase. Okay, it has to switch its phase whenever there is a symbol transition, which means that, let's say this is X1 and this is X2. So if X1 is there, if next symbol is also X1, then it need not have to do any transition 0 degree. But if the next symbol is X2, then again it has to do 180-degree transition from here to here. But again, if there is a X2, it will remain here only. But again, if there is a X1, yeah, it has to do transition. So while doing transition, basically, like, it has to pass the center. Like, you take pi by 2 BPSK, your constellation. Once you do the modulation based on the equation given in the spec, you will see that how does it look? I think your constellation will look like this. So now we will have 4 points, not just 2 points. Now, if you are in X1, either you will go here or either you will go here. So from X1, you will never go to X3. And like that, only the transition will happen in these directions. Okay, here the phase difference is 0 and this is 90 degree. So there is a less phase difference, less burden on the power amplifier, and also this will not cross the origin, and this will help in your low PAPR. So we have to see that equation. So ideally, you will have only these 2 points. So now this is X1. Let's say this is X3. Now you take this first sample. Okay, let's say X1, then X3. X3, X1. There will be only this one when you actually do the first time. Okay, but each of these IQ, you also have to multiply with another phase factor, which is 0. Then X3 e to the power of j 1 into pi by 2. So then X1 into e to the power of j 2 into pi by 2, like that. So when you do this, then after doing this, if you see, you will have 4 points. So this is just from year to year, one phase addition will be done. And this is our IQ. Okay, this will be transmitted. In the receiver side, first they will do the reverse operation of this. Okay, all of this reverse operation will be done, and they will get back this one, X1, X3, plus some noise. Okay, these are all, like, let's say, noise. Then the point might be lying somewhere here. Then they will do the normal BPSK demodulation to get back the original BPSK. Yeah, this equation will be given in spec how you need to multiply each and every IQ. PUSH data also we are using. See, for reference signal, there are low PAPR sequence itself. Okay. But for PUSH, especially in case of transform precoding enabled case, it calls for pi by 2 BPSK if UV capability is enabled, or if UV supports it. That is one case, pi by 2 BPSK. For PUSH data, we can use it. Okay, if you want low PAPR conditions. And the second one is, if you see PUCCH channel, PUCCH format 3. Format 3 also has this low PAPR requirement. There again, to transmit the UCI bits, it will ask for the modulation. So there it can be to BPSK or it can be QPSK.